Okay, hi everyone. Now in this topic, I'm going to explain about the reaction rate. What is reaction rate? And I'm only going to cover a few small topics first, which is the definitions of reaction rate and how to write the differential rate equation and determine the reaction rate based on the differential rate equation of a reaction. So basically in this video, I'm going to cover 1, 2, and 3. Okay. Now let's see. All right. So when we say reaction kinetic, it is related with reaction rate. Okay, so reaction rate, okay, I don't want to talk about what is chemical kinetics and what is kinetics. You know that kinetics is movement of change. Now let's directly go to the rate of reaction. Okay, now the definition of reaction rate, as you can see here, it is the change in the concentrations of a reactant or a product with time. Okay, and the main one is change of concentration and also the time. Now, we are talking about concentration and we are talking about time. And that is why, in the end, when we want to see the unit, we are going to have this mole per liter, which is the concentration over time. Okay, so to get the change of the concentration, it is to get that you need to calculate, which is the final concentration minus the initial concentration and over the time. Or of course, if we look, because this is changed, so we are going to put delta sign over there. Okay, so again, when we are talking about reaction rate, we are talking about the change of concentration. Okay, the change of concentration, this one, over time. Okay. So you can consider the following reaction here. Okay, so we have our reactant A. Sorry, this is A. A is our reactant. And B is our product. So of course, we know that initially we only have reactant and over the time, product will be produced. And that is why you can see a graph like this. Okay, so let's take a look at A. So A is here because here is 0. 0 means you have nothing yet. Okay, so we have some amount of A. Say this is 1.0, say. And then over the time, okay, as the process start, the concentration will decrease over the time. Okay, or maybe even can get 0. But at the same time as the concentration of A decreasing, B will be produced. And that's why the graph is like this, where B is produced. So, as a result, A decreases. That is your reactant. Reactant will definitely decrease. B, which is your product, the concentration of B will eventually increase with time. Okay, with time. So that's how are you going to see the graph. And we can also calculate the rate of the reaction by using what we call as pembezaan, this one, okay, perbezaan, this one. Okay, so we use this oh sorry, I forgot the terms. Yes, differential. Okay, the differential rate equation to calculate the rate. Okay, now one thing for you to remember, okay, the unit of reaction rate is m per time. So we know m is referring to concentration. Okay, so time is time. But if you remember, because we said time is a general thing. So time can be in second, Okay, time can also be minute, can be hour, can be day, and can be year. Okay, so time can be anything. It not necessarily should be second, but most of the question come out in second, but sometimes there's a time it come out with year. Okay, so this is like some sort of conclusion when the rate of reaction is inversely proportional to time, which means the shorter the time taken for the reaction to progress, the higher the rate of reaction. Which means semakin cepat dia punya rate of reaction semakin tinggi. Okay, now talking about the differential rate equation. Okay, so this is a little connected with mathematics. When we are going to find the differential rate equation, we are actually looking for the speed. All right, so it is had the connection with the rate equation as well. Now, you can see here, say you have a reaction A produce B. Now, how are we going to write the differential rate equation? Okay, macam mana kita hendak menulis differential rate equation? I know you can see here, but I will write for you as well. Okay, so we have to start with the word rate. Now, most of the students in exam, they don't write this rate. So if you don't write the rate, you're not going to get the mark. You have to write the rate, okay, the word rate. Now, we will start with A. So for A, now because this is reactant, we know reactant will decrease. So we have to write negative here. D concentration A over dt. So this is the differential of the concentration over time. Oops, sorry. And then equivalence to, now B is product. Product is increasing. So if it's increasing, we have to write the symbol positive. So we differentiate the concentration and the time, and we are going to get the speed. Okay, so as you can see, it is the same thing here. Now let's take a look at the second one. Okay, 2C produce D. So for 2C, again, you have to write rate equivalence to, now C is reactant, so we need to put negative. However, this time we have 2. So we have the stoichiometry true. We are going to write 1 over 2. D, concentration of C, time, and then equivalence to D. D is product, no stoichiometry. Stoichiometry is 1. So we just write plus D over dt. Okay, so that's how we write the differential rate equation. Again, this is must, wajib. You don't write, if you just write like this, you're not going to get mark, okay? If you don't write the symbol also, you will not get mark. So this is the right way to write the differential rate equation. Okay? So generally for the reaction here, we are going to write rate equivalent to 1 over A Okay, there you go. So this is how we write it. All right. Now let's take a look at the exercise. I will only give you one, which is 1A, and then for 1B, please do it by yourself. Now write the differential rate equation for A. So I'm going to write it as this, rate. Now our nitrogen gas is reactant, so we are going to write it like this, which is equivalent to hydrogen gas is reactant as well with 3 stoichiometry. So we put 1/3. Okay, this. And our ammonia is product. Okay, so there you go. I have the red, I have the symbol, and I have everything. Now, let's try to question B. You can pause and then you can continue. Now, let's consider question 2. Consider the reaction between zinc and argentum nitrate to form zinc nitrate and argentum. Okay, so as you can see, we have the equation here. Okay, first question, write the differential rate equation for the above reaction. So my answer would be red Okay, now I have the product here. So don't forget to put the symbol positive. It is a must. Okay, this one. Right, did you get it right? I hope so. Now, let's take a look at question 2b. How are we going to write how are we going to solve question related with calculation? Now, when concentration of zinc ion is increasing at 0.25, what is the rate of decrease of argentum ion? Okay, so as you can see here, we have zinc and we also have argentum, which related with this and this. So we bring down, okay, this, which is equivalent to this one. Now, everyone, okay, this 0.25 is referring to the speed, and this is speed. Therefore, this 0.25 is equivalent to what you write here, which is 0.25 ms negative 1 equivalent to 1/2 over this. Now, since the question is asking you the rate of decrease, so the rate of decrease is actually referring to this argentum over dt, this one. So, to solve it, 0.25 ms negative 1, this one, these two go up and multiply with it. So we are going to get 2, therefore we are going to get 0.50 ms negative 1. Okay, so again, right, this differential reaction is equivalent to the speed. So just substitute it here. And then since we are looking for the rate of decrease, which means this one only, so the 2 here you have to bring up and times with the 0.25. So let's try question number 3, and we will discuss it in the class later. Okay. Thank you, everyone.